Alright guys, what we have up next is the volume of compound figures. So if you remember back when we were doing surface area, we did all the formulas for all the different shapes, and then we started to combine them, right? And so you had to kind of like break them up into certain pieces, and then find the area of the individual pieces, and then add them together. Same thing here with volume. Alright, so a compound figure is a figure made up of two or more 3D shapes. Now, the shapes can be added together, kind of like stacking, right? Or it could be the cutting of a figure out of something that's already existing, right? Now, we're not going to do this. I'm not going to probably put this on any of the homework or on any of the quizzes, but I'm just going to talk about it just so you see what it looks like, and it's actually not that difficult. So let's first talk about what this would look like as far as a problem, right? So right here I have a rectangular prism, right? Now that is a singular shape. There are not two shapes present or two figures present. But if I start to draw on the top, I've now created a pyramid on the top, which means the volume, think of this as if this was a one solid figure, right? And I wanted to fill up this with water. The volume of our compound figure now would be the volume of the rectangular prism plus the volume of the pyramid that's stacked on top of it. So it's not like surface area where we have to worry about, okay, what can we not see and what can we see. With volume, it's really simple. You're either going to be adding the volumes together or subtracting a volume from another one. So for this problem right here, that would be the volume of the rectangular prism plus the volume of the rectangular pyramid. Okay, and we're not going to do that problem, but that's all you would have to do. Find the volume of the rectangular prism, find the volume of the pyramid, add them together. Let's look at this next shape. So here we have a cone, right? But now if I were to stack half a sphere on there, again, the volume would be whatever the cone's volume was plus the volume of half that sphere. So volume of the cone plus the volume of half the sphere. The reason why it's only half is because that sphere is cut directly in half. So again, guys, you're just adding things together. Now, an example of something where it would be like cutting it out, right? So imagine we had this box or a block, and we just cut a rectangular piece of it straight out, right? So hopefully that three-dimensional diagram helps you see what I'm talking about. But imagine you had a piece of wood, right? And then you wanted to cut a rectangular block out of that piece of wood. You'd be subtracting volume away from that piece of wood, because if you were to, let's say, put it in a box, it's not going to take up as much space because technically something could fit inside that middle piece that you cut out. So for this problem, it would be volume of the prism, or like I said, big prism, minus the volume of the little prism, the piece that you cut out. Because I'm taking volume away from that block by cutting that piece out. But like I said, we're not going to probably do any of those type of problems. The main two you're really going to be looking at, the main types are the ones where we're going to be adding volumes together. So on the next slide, we're going to do two examples, and then you'll have a few problems for homework. So here, right, this looks like a house, right? It's got the rectangular prism, or actually the square prism on the bottom, and then we have a triangular prism on top. So this one's different than the example. The last one had a pyramid stacked on top of it. This one has the triangular prism. So we need to find the volume of the square prism, and then we're going to add that with the volume of the triangular prism. I don't know why I wrote of twice up there. So let's start with the simple base. So we know that volume of a prism is just area of the base times the height. So our height of our prism is 8 feet. So h equals 8. And our base area is 15 times 15. So 15 times 15 is 225. So the volume would be 225 times 8 for 1,800 feet cubed. So that is for, again, this bottom rectangular prism. Now for our triangular prism that's on the top, our volume is still B times H. All right, remember now height is the distance from base to base. This triangle is one of our bases. There'd be a triangle in the back as well, all right? So the distance, or the height, would be that length there, which is 15. Our base area, because it's a triangle, is 1/2 lowercase b base, which is also 15, times the height of our triangle, which would be 6. So 1/2 times 6 is 3, 15 times 3 is 45. So our volume is going to be 45 times 15. So 675 feet cubed. So all we're going to do is we're going to take those two amounts and we're going to add them together. So total volume equals 675 plus 1,800 for a total volume of 2,475 feet cubed. Okay. So again, we found the volume of the rectangular or the square prism on the bottom, and then we added that with the volume of the triangular prism stacked on top. Let's look at this problem here. So this is a cylinder with half spheres stacked on the end. All right, so it looks kind of like a capsule or a medicine pill. So because we have half spheres on the top and the bottom, if we were to combine those, that would make one whole sphere. So we can just find the volume of one sphere, and then add that with the other part of this figure is our cylinder. So we need the volume of the cylinder. Okay. All right, so let's start with our sphere. So we know that volume equals 4/3 pi r cubed, and our r based off our diagram is 4. So 4 to the third power. 4 to the third power is 64. So we have 4/3 pi times 64. 64 times 3.14 is 200.96. So we have 4/3 times 200.96. And like I said on the previous one, do 200.96 times 4. That gives us 803.84, and then divide that amount by 3. So our volume of our sphere is 267.9 centimeters cubed. So we're going to come back to that after we find the volume of the cylinder. Now our cylinder, same as a prism. Volume equals area of the base times the height. If we look at our cylinder, our height is 12. And then our base is going to be pi r squared. So pi r squared. So that's going to become 16 times 3.14, 50.24. So that means then that our volume equals 50.24 times 12. That gives us a total of 602.88. So we take that volume, add it with the volume of our sphere, so total volume equals 602.88 plus 267.9 for a total volume of 870.78, running out of room, centimeters cubed. And that about does it. Okay, guys, so let me know if you have any questions. Hope everything's going all right. Talk to you soon.